Quantum technology is rapidly becoming a game-changer in national defense, and Canada is at a crossroads that could define its future security and technological independence. The Canadian government has elevated quantum tech to a top priority as it works to ramp up defense spending and strengthen its sovereign capabilities. But here's where it gets controversial. Will Canada move fast enough to avoid falling behind again as it did with artificial intelligence? Quantum technologies, ranging from advanced computers to ultra-sensitive sensors, are alongside other groundbreaking innovations like AI and drones that are revolutionizing modern warfare. Many countries are now frantic to integrate these tools because traditional military systems risk becoming obsolete against new digital threats. This is why Canada launched a bold 7-year initiative 2 years ago aimed at harnessing quantum technology for defense purposes. Meanwhile, global powers aren't standing still. The U.S. is aggressively funding the development of a dependable quantum computer by 2033, and China is investing billions in this promising field. Canada once led the world in AI research, but lost its edge. The looming question is whether the country can avoid repeating that mistake in the quantum race. Around the world, nations prioritize computational strength over sheer manpower, betting that whoever masters quantum tech first will reshape warfare, both as a powerful defensive shield and a potentially devastating threat. Lisa Lambert, CEO of Quantum Industry Canada, emphasizes this opportunity. Only a select few countries possess the quantum capabilities Canada currently has, making this a key area for collaboration within global defense alliances. Quantum technology's military applications can be broadly divided into 3 categories: communications, sensing, and computing. Starting with sensing, radar is crucial for detecting objects on land, sea, and air. Yet, today's military radar systems can often be identified and evaded, putting users at risk. Quantum-enhanced sensors promise to change that by making these systems effectively invisible to adversaries. Jérôme Bourassa, CEO of Qubic Inc., which operates in Sherbrooke and Waterloo, is developing a quantum radar that can spot threats, such as drones, without being detected. Imagine seeing your enemy without them knowing you're watching. The enhancement is all about the quality of information provided, not how it's accessed or used. Quantum-powered radar is one of 4 priority missions cited in the Canadian Department of National Defense's Quantum 2030 strategy, released in 2023. According to the strategy, this technology could potentially detect stealth aircraft and provide a stealthy mode of detection itself, offering much sharper imaging capabilities. When it comes to communications, quantum technology presents a paradox. On one hand, the arrival of scalable quantum computers threatens to break the classical public key cryptography that secures much of today's digital communication. On the other hand, the same technology could be used to build quantum-safe communication channels that are virtually unhackable. The exact timeline for when quantum computers will crack current encryption methods remains uncertain, but companies like Quantum Bridge Technologies in Toronto are already developing these quantum-resistant systems. To stay ahead of potential cyber threats, Mattia Montagna, CEO of Quantum Bridge, warns of the stakes. If adversaries gain quantum decryption capabilities, much of the Internet's formerly secure communications would be exposed as plain text. This scenario, which he terms harvest now, decrypt later, is exactly why Ottawa has committed to making quantum-secure communication another pillar of its Quantum 2030 plan. As the government states, it's not a question of if, but when quantum machines will break today's cryptographic protocols. Finally, in computing, the immense power and speed promised by quantum computers are driving defense innovation. Christian Wiebrook, founder and CEO of Toronto-based Xanadu Quantum Technologies, highlights cybersecurity as a prime example. Without the most sophisticated encryption and decryption capabilities, nations would find themselves severely vulnerable. Canada is clearly aware of these stakes, dedicating another Quantum 2030 mission to developing quantum algorithms to boost classical defense computing capabilities. Similarly, the U.S. is supporting a fierce competition among companies, including Canadian firms, to produce a commercially viable quantum computer by the year 2033. However, until such a device is operational, the advantages and risks linked to quantum in defense remain largely speculative, notes Dr. Stephanie Simmons, founder and chief quantum officer at Vancouver's Photonic Inc. She stresses that Canada must keep pressing forward, honoring its Quantum 2030 commitments and avoiding bureaucratic delays that could squander its momentum. Canada is trusted globally, and trust is essential for this technology. Leveraging our reputation and talent pool is crucial. We cannot afford to let internal inefficiencies hold us back, Simmons says. So here's the critical question. Can Canada rise to the occasion this time and become a global quantum leader for defense? Or will it fall victim to the same pitfalls that hindered its past technological ambitions? The answers matter deeply, not only for national security, but for the very future of warfare in the digital age. What do you think? Is Canada ready to seize this quantum moment? Or will the clock run out?